Now let's talk about the CAPM and index model. Let's estimate that. Okay, so to estimate this model, we have to use the real data called the holding period return, right? Historical data. Historical data, right? We use the data when you estimate this alpha and beta using these real numbers. So this is the market risk premium. We can usually use the index return for the market returns and the TB rate for risk-free rate. And we use real numbers and estimate best fitted line. So if you estimate best fitted line, this is the observation of each. This is the expected return of the individual. This is the expected return on S&P 500, which is index returns. Actually, this is risk premiums, okay? So this is risk premium of the I. This is risk premium of the market. Then we find this best fitted line. And this is called SCL. SCL, security characteristic line. And you can actually have SCL, which is this case. This is intercept, right? This is the intercept. This is alpha, and the slope is beta. So how can you find SCL? We find SCL using the data again, these datas. And we basically, when we find data using the regression analysis, okay, when you do regression analysis, you find this coefficient. When you find this coefficient, now we want to know that, first of all, this alpha is valid. Look at the p-value. If the p-value is, say, greater than about 0.1, 10%, then we usually don't have any evidence that this coefficient is actually not zero. It means that it is, I don't say it's zero, but we don't have evidence that it is not zero. So this is kind of not valid. No alphas. And 1.20 beta is not valid because this p-value is very, very low. So usually if p-value is below 5%, and this is quite trustable, at least it should be below 10%. So the security characteristic line is basically the plot security expected access return, which is risk premium over risk-free rate, right? As a function of access return on market. Now this required return, so it's going to be using this risk-free rate plus beta times expected return of the market minus risk-free rate, right? We can estimate that. So go back to here again. We have we have regression models using, again, this one is y variable, this one is x variable. Regress it and find it. When you find the alpha and beta, we can actually have the predicted value, right? So using alpha and beta, we have predicted value using the market factor, and this is a realized returns, and there is some gap between two, then that's called the residuals. We expect that the sum of residuals are close to zero. Okay, then this is best fitted line. So we try to minimize this residual. That's how regression works. Okay. Now I have real data here. Okay, which is, you can download this data on Google, and if you see this spreadsheet, then I download Google share price from August 1st, 2011 to 2016 August 1, and I calculated. See, so this is the share price, this is the market index, S&P 500 index price, and this is the US T-bill rate. This is T-bond rate. So I compute. Now this is the return for each month, right? So this is return for Google, return for market, risk-free rate, and then compute the risk premium for Google and the market by subtracting like the return Google minus risk-free, return market minus free, and run a regression. So how to run a regression? Go to data, I'm sorry. And you can go to data analysis, but if you don't have data analysis, then let's go to file, go to option, and then there's add in, and go to add in, and you have to click analytical tool file. Then now you have data part, there's data analysis, right? So data analysis, find regression. There's regression part here. Now your Y is this one, return risk premium of Google, right? So risk premium of Google, pick it and drag it to the end. The missing variable automatically deleted, okay? And then the X range is market risk premium, right? So drag here to the end, okay? And we have labels at the top and regress. There's some errors here. Maybe just let's start 3, okay? And there's no label. Again, run it. Yeah, it's running. So we find this number's a little different to the numbers that we saw in the previous slide because our data is different, right? But at least we know that this is the beta. Now p-value is very low, so this beta is working, 1.02. Now intercept is 0.008, I'm pretty close, and see the p-value 25%, which is pretty high, right? So this is not really valid because probably Google doesn't make any alpha, but the beta is about 1.02, 1.20 previously. It's kind of like the pretty close to the market beta right now. And you can regress using this data set. So you can practice it using the file on Moodle.